So this is your YouTube video for day 2 of New Jersey Seeds Physics. Just wanted to go over the equations again, what each one of the variables means, and then I wanted to do a homework problem very similar to what you have on your homework number 2 assignment. So we have the big 4 equations right up here on the board. V is equal to V0 plus AT. Delta X equals V0T plus 1/2 AT squared. V squared equals V0 squared plus 2A delta X, and delta X is equal to V plus V0 over 2 times T. We want to go over what each one of those variables means. V0 is the initial velocity. That's the starting velocity in the problem. V is the final velocity. That's your final velocity. That's your ending velocity on the problem. A stands for acceleration. We remind ourselves that acceleration is the rate of change of velocity. So if the velocity is changing, you have an acceleration. Delta X is our change in position, so that's how far you travel during the problem, and T is the time. Now on the homework, you guys have a tricky question similar to this one. An object is thrown upward with an initial velocity of 40 meters per second. How long does it take to reach max height, and what is the maximum height? Okay, when we have a word problem like this, we want to rip out as much information as we can. So an object is thrown upward with an initial velocity of 40 meters per second. So we know right away, initial velocity, 40 meters per second. That's good, okay? Now, how long does it take to reach max height? What is the max height? It doesn't feel like we have a lot of information here. However, if you remember our lecture for day 2, we talked about how at maximum height, an object's velocity is 0. So that means the final velocity for this object is 0 meters per second. Now, since gravity is acting on this object, that means the acceleration on this object comes from gravity. And I told a few classes this, the acceleration from gravity is always -10 meters per second squared. -10 meters per second squared. It's negative because gravity's acceleration is pointing downward. Since this velocity starts positive and goes to 0, we know that the acceleration should be negative. With all this information, we should be able to solve for the time very easily. So I would use V is equal to V0 plus AT. V0 equals 40 meters per second plus a -10 times the T. Make sure to include the minus sign on that 10, or else you're not going to be able to get the right answer. You have to include the minus signs where appropriate in the equation. Bring the 40 to the other side, that's going to make -40. Then we're going to have -40 is equal to -10T, divide by -10, and we get an answer of 4 seconds. Now, with that answer of 4 seconds, we should be able to figure out the delta X, the displacement of the object. I'm going to do it 2 ways. The first way I'm going to use is the 4th equation. V is equal to, delta X is equal to V plus V0 over 2 times T. So I would have delta X is equal to, the final velocity is 0, initial velocity is 40 divided by 2 times the time of 4 seconds. And we should get 40 divided by 2 is 20. 20 multiplied by 4 is 80 meters. So that's one way to do it, okay? The other way to do it, I'm going to use delta X is equal to V0T plus 1/2 AT squared. We haven't used this equation too much, that's why I chose to use it. We've got delta X, I'm sorry that the handwriting is getting a little small here. Delta X is equal to V0 is 40. The time is 4 seconds plus 1/2. We have to include the minus sign on the acceleration, 10 meters per second squared, the same way we did over here. So we've got -10, and then we multiply by 4 squared right here, okay? So make sure, 40 multiplied by 4, that's V0 multiplied by T, plus 1/2 AT squared, so plus 1/2 -10 times 4 squared. That's going to be 160. This over here is going to be 80 because that's 16 multiplied by 10, -10, which is -160. 160 divided by 2 is 80 with a minus sign, so that's 160 minus 80, so we also get 80 meters. So 2 different ways to solve the problem when it comes to delta X. There actually is a 3rd way, maybe you guys can figure that out. But let's go through the problem again. An object is thrown upward with an initial velocity of 40 meters per second. How long does it take to reach max height? And what is the max height? The initial velocity is 40 meters per second. The final velocity, since we get to max height, is 0, and the acceleration is caused by gravity. That's what's causing this object to slow down while it rises. That's negative 10 meters per second squared. V is equal to V naught plus AT will allow us to solve for the time. And then I can use delta x is equal to V plus V naught over 2 times t, or delta x is equal to V naught t plus 1/2 AT squared. Both answers will give me 80 meters. You will always get consistent answers so long as your work is consistent. A lot of times there are multiple ways to solve the problem.